Welcome to an incredible journey through the intriguing and enigmatic moons of Jupiter. Jupiter, the largest planet in our solar system, is home to a stunning collection of over 79 moons. Each one has its unique characteristics and mysteries. Today we'll focus on the four most famous and fascinating: the Galilean moons, Io, Europa, Ganymede, and Callisto. These moons, discovered by Galileo in 1610, are some of the most explored celestial bodies in the solar system, and each harbors secrets that captivate astronomers and scientists around the world. Number 1, Io, the volcanic inferno. We begin our journey with Io, the fiery and volcanic world. Io is the most geologically active moon in our solar system, with over 400 active volcanoes spread across its surface. The reason for this intense activity lies in Io's powerful interactions with Jupiter's gravity. As Io orbits close to this gas giant, the immense gravitational forces pull and stretch Io, creating friction that heats its interior. This tidal heating is responsible for the incredible volcanic eruptions that define Io's landscape. Footage of Io's surface with simulated volcanic eruptions and lava lakes. Io's volcanoes are constantly changing its appearance, creating a landscape of molten lava lakes, towering mountains, and vast plains covered in sulfur deposits. These sulfur compounds give Io its characteristic yellow, orange, and red colors. Some of its volcanic plumes are so powerful that they can shoot material up to 300 miles above the moon's surface, forming a temporary atmosphere around Io before it's swept away by Jupiter's magnetic field. Shot of Jupiter's magnetic field affecting Io. The intense gravitational pull from Jupiter doesn't only fuel Io's volcanism, but also contributes to Io's position within Jupiter's powerful magnetic field. This interaction generates powerful electrical currents, with voltages reaching up to 400,000 volts and currents of 3 million amperes. This causes Io to emit radiation, making it a dangerous place for any potential spacecraft to explore. Despite this harsh environment, Io remains a focus of scientific interest, as studying its extreme conditions helps us understand volcanism on Earth and beyond. Number 2, to Europa, the ice-covered ocean world. Leaving Io, we move on to Europa, one of the most promising places in the solar system for finding extraterrestrial life. Unlike Io, Europa is covered in a thick layer of ice, hiding what scientists believe is a vast ocean underneath. This subsurface ocean, kept warm by tidal forces similar to those affecting Io, may contain twice as much water as all of Earth's oceans combined. Footage of Europa's icy surface, with cracks, ridges, and potential plumes. Europa's surface is a smooth, icy shell crisscrossed with long, dark cracks and ridges. These features likely form as the ice crust expands and contracts, possibly indicating tectonic activity similar to Earth's. Scientists also suspect that water plumes may occasionally erupt from beneath the surface, bringing materials from Europa's ocean up to the surface. If confirmed, these plumes could allow scientists to study the composition of Europa's ocean without having to drill through miles of ice. To close-up shot of Europa's potential for life. What makes Europa particularly exciting is the potential for life within its ocean. Here on Earth, life thrives in deep-sea hydrothermal vents where sunlight never reaches, and scientists believe similar conditions could exist in Europa's hidden ocean. Complex chemistry, a source of energy from tidal heating, and the presence of water create an environment where microbial life could theoretically exist. Cut to animation of NASA's Europa Clipper mission. To explore these possibilities, NASA's upcoming Europa Clipper mission will study Europa's surface, atmosphere, and potential plumes in detail. Set to launch in the 2020s, this mission will map Europa's ice shell, assess its habitability, and search for biosignatures or signs of life. With over 40 planned flybys, Europa Clipper could revolutionize our understanding of this icy world and its potential to support life. Number 3, to Ganymede, the giant moon with a magnetic field. Next, we travel to Ganymede, the largest moon in the solar system. Ganymede is larger than the planet Mercury and has a unique distinction. It's the only moon known to have its magnetic field. Scientists believe that Ganymede's magnetic field is generated by a liquid iron or iron-nickel core, similar to Earth's, making Ganymede the only moon with a structure resembling Earth's magnetic dynamo. Footage of Ganymede's surface, showing auroras and unique geological features. This magnetic field creates stunning auroras at Ganymede's poles, visible as shifting bands of light when viewed through powerful telescopes like the Hubble. Ganymede's surface is a mix of dark, ancient areas covered in craters and lighter regions that indicate more recent tectonic activity. These younger regions are marked by grooved terrains, which are believed to be the result of tectonic forces or past ice movements. Cut to interior structure of Ganymede and potential subsurface ocean. Like Europa, Ganymede is thought to harbor a subsurface ocean, though it's buried much deeper beneath a thick icy crust. This ocean could contain more water than all of Earth's oceans, though its depth makes it more challenging to study. Scientists are fascinated by the possibility that Ganymede's ocean might contain unique ecosystems or complex chemistry, even if the odds of life existing there are less favorable than on Europa. Animation of the European Space Agency's JUICE mission. In the coming years, the European Space Agency will launch the JUICE mission, Jupiter Icy Moons Explorer, which will conduct detailed studies of Ganymede, Callisto, and Europa. This mission will focus on Ganymede, aiming to understand its internal structure, magnetic field, and potential for supporting life. Ganymede's status as a magnetic moon with an ocean makes it a compelling target for exploration, and JUICE will bring us closer to uncovering its secrets. Number 4, to Callisto, the ancient and mysterious moon. Our final stop is Callisto, a moon that stands out for its heavily cratered surface in ancient history. Unlike Io, Europa, or Ganymede, Callisto shows little evidence of geological activity, which is why it's often called a dead world. Callisto's surface is pockmarked with craters, remnants of a violent past filled with collisions with asteroids and comets. Footage of Callisto's cratered landscape, including the massive Valhalla crater. One of Callisto's most impressive features is the Valhalla crater, a massive multi-ringed structure that spans hundreds of miles across the surface. This impact basin, along with the many other craters, gives Callisto an ancient appearance, almost like a frozen time capsule. Scientists believe that studying Callisto's surface can reveal information about the early solar system, as it has remained largely unchanged for billions of years. Discussion of potential for life in subsurface ocean on Callisto. Though it may seem lifeless, Callisto could also harbor a subsurface ocean, kept liquid by the small amount of heat from radioactive elements in its core. This ocean, if it exists, lies far beneath the icy crust, and any life there would be limited by the lack of energy sources. However, Callisto's isolation from Jupiter's harsh radiation makes it one of the safer options for a future human base. NASA has considered Callisto as a potential outpost for missions deeper into the solar system due to its distance from Jupiter's radiation belts to Jupiter's magnetic field and radiation belts. All 4 of these Galilean moons orbit within the powerful magnetic field of Jupiter. This magnetic field generates intense radiation belts that make exploring these moons challenging. Europa and Io are heavily bombarded by radiation, while Ganymede and Callisto, being farther out, receive less but still significant exposure. Understanding Jupiter's magnetosphere and its effects on these moons is critical for planning future missions and assessing the potential habitability of their surfaces and subsurface oceans. To potential future missions and explorations. The exploration of Jupiter and its moons is only beginning. Future missions, such as Europa Clipper and JUICE, will provide unprecedented insight into these icy worlds. Scientists are also considering concepts for landers or subsurface probes that could drill through Europa's ice or even swim through its ocean to search for signs of life. Each new mission brings us closer to answering one of humanity's biggest questions. Are we alone in the universe? Closing footage. Jupiter and its moons, set against the stars with hopeful music. Jupiter's moons are more than just satellites orbiting a gas giant. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon so you never miss an update. Thank you for your support.